All right, hey, Algebra. It is our week 5 module notes, and we're going to go back and kind of review a little bit of graphing quadratics, which I know you guys were super pumped about. But we have two forms that we're going to be addressing, right? We've got our vertex form, which is going to be more of a review, okay? And you have one assignment this week that's about the vertex form. And then we're going to talk about standard form. So really we're just looking at the graphs of quadratics right now. Okay, and then the first one, just as a review, standard form, we have our parentheses, squared, we have the -3 on the outside, and there's some tricks to this one, okay? It's called vertex form for a reason, because our vertex is listed for us right here and right here, all right? So our vertex is going to be whatever's going to zero out this parenthesis, which would be -2. So when x is -2, plus 2 is 0, right? So our vertex is going to be at -2. And then the number outside is our shift vertically, okay? So that means we're going to go down 3. So our graph vertex is going to be -2, 1, 2, 3. Going to be right here is going to be our vertex, all right? Now, if you remember with a quadratic, when we're doing this type of graph, a quadratic is a U shape, all right? And one of the tricks that I had given you guys is once you have your vertex established, you look to the front, and there's no number here, which means actually it's just the number 1. And I want you to think about if you move to the right 1 and then square that. 1 squared is 1. Now, Mr. Mock, how do you know that? How do you know that's the next point? Well, if I take -1, because right here x is -1. If I put -1 right here and put -1 plus 2, -1 plus 2 is going to be 1. 1 squared is 1. 1 minus 3 is -2, and look at that, it works. Now, because we're graphing a parabola, we are also going to have this thing called a line or an axis of symmetry, which is going to go basically, it's just this dotted line that goes right through the vertex, okay? So your axis of symmetry is always whatever the x value of the vertex is. So your axis of symmetry is going to be x equals -2. So that's your axis of symmetry. Right, that's your axis of symmetry is right here at x equals -2. You've got your vertex at -2, -3, and now it mirrors on either side. Over 1, up 1. Now, the other thing we talked about is if you go over 2, you square 2. What's 2 squared is 4. 1, 2, 3, 4. You would do that on the other side here, and you have your parabola graphed. Okay, and again, to check it, if I go over 2, that's at 0, put in x is 0, 0 plus 2 is 2, 2 squared is 4, 4 minus 3 is 1. So it gives you that point, okay? So you've got that over 1, up 1, over 2, up 4. The next one would be over 3, up 9, right? Because 3 squared is 9. We're doing a quadratic. We're doing with squareds, okay? So that is a review. We've done these before we had our long break here. This is a review of those quadratics, okay? Now we're going to go over to number 2. Number 2 is I want to write the equation, okay? So I have to think about what is the vertex. The vertex is here. I'm counting over 1, 2, 3, 4. And then down 1, 2, 3, 4, 5, 6, 7. So I have to list what my vertex is. It's going to be 4, -7. All right. So now when it comes to writing that equation, I know that it's going to be x is a +4. Here it was a +2, but then it made it a negative, right? So I have to think when x is 4, it's going to zero out. So it's going to be x minus 4 squared, so it's the opposite. And then it's down 7, so it's going to be minus 7. So I'm writing the equation now. But we can't think we're done because we always have to check for that multiplier. Like here it was 1. Here, notice that I'm going over 1 up 2. It's supposed to be over 1 up 1 if there's not a number here. But I'm going over 1 up 2. I'm going over 2 up 1, 2, 3, 4, 5, 6, 7, 8. And the trick is, when you're looking for the multiplier or the number that goes in front, you're just going to pick this number. All right? So over 1 up 2, that means the multiplier is, in fact, 2. Well, Mr. Mock, I mean, that's nice and all. It seems like a shortcut. Does that work every time? Well, you can always check it, right? Over 2, if I go over 2, just like over here was over 2 up 4, well, how the multiplier works is if you go over 2 up 4 and then multiply that by 2, because that's what I call it, it's the multiplier. So over 2 up 4, 4 times 2 is 8. So actually it works. So if we were to continue this graph, we'd go over 3, 3 squared is 9, use the multiplier, 9 times 2 means I'd go up 18 and go just right off the page over here. Okay, so that's how the multiplier works, and that would be how you would write this equation. So now if we talk about the axis of symmetry, the axis of symmetry would be at x equals 4. We have our vertex, we have our equation, we've established all that we need, all right? So that's just that quick review of vertex form. If you want to take a pause right now and do that first assignment, that's in Pearson, go ahead and do that, and then you can come back to this video at about the 7-minute mark. I'm going to go ahead, though, and transition now into graphing quadratics using standard form. So standard form is a little bit trickier, all right? I don't have the given vertex like I did up in the first 2 examples. This is like standard form. This is stuff that we've been factoring. And we're going to look for, not in this particular problem, but down the line here soon, what do the factors of a quadratic, how does it connect to the graph? But for right now, I want to give you the shortcut on how to figure out the vertex for this particular standard form quadratic, okay? There is this little shortcut, and it works like this, okay? We're going to use this thing. It's called x equals negative b all over 2a, okay? And I'm sure you're thinking, well, I don't know what that means. Let me show you. The a and the b connect to the coefficients in the first 2 terms, okay? So in this case, a is the first or the leading coefficient. In this case, a equals -3. And then b is the coefficient of the second term. In this case, b equals -6. Well, that's -6. Yeah, -6 it's a -6, okay? So knowing that, we can plug this in to figure out, and this is going to give us the x value of the vertex. Gives us the x value of the vertex. All right, so it's negative b. Well, b is -6. That means it's going to be -6 over 2 times a, which is -3. So then when we do this, we have -6 is a +6 over 2 times -3, which is -6. 6 divided by -6 is -1. So here we are. We now have the x value of the vertex, which is -1. How does that help us? Well, it helps us because if I know the x value, if x equals -1, We have been talking all year about if you know the x, you can figure out the y by plugging it in. So you want to plug x equals -1 into the equation to find y. That'll give us the vertex so we can start graphing this guy, right? So now y equals -3, but x is squared, so it's going to be -1 squared minus 6 times -1 minus 5. And when we continue this, you get -3, -1 squared is 1. This is going to be plus 6, because -6 times -1 is a positive 6, minus 5. -3 times 1 is -3 plus 6 minus 5. -3 plus 6 is going to be 3 minus 5. And guess what? Y is going to equal -2. So now I have my vertex. My vertex is at x is -1, y is -2. So I can start graphing this. Now, before I draw my graph, I want to think about some things. Let's look. Here's my standard form equation. This right here, this number, would be just like the multiplier up here in vertex form, okay? This -3 is the multiplier as well as the leading coefficient. It's negative, which means my graph is going down, and I'm going to multiply by 3. So it means it's going to go like super quick in the negative direction. So let me go ahead. It's going to be at -1, -2, so it's going to be over to the left. So it's going to help me kind of plan out how I'm drawing my graph here. I'm going to go this way. I think I'm on the page. I haven't looked at my screen here. I'm going to go this way, and then I'm going to go this way with it. Boom. Okay. So let's see what happens here. I have my vertex is -1, -2, -1, -2. There's my vertex, okay? My axis of symmetry is going to be x equals -1. Keep that in mind. We're going to need to know that. And then when I'm thinking about this graph, right, I have this -3. So it means I'm going to go over 1, down 3. 1, 2, 3. Over 1, down 3, 1, 2, 3. So now look at this, I have a y-intercept. And then I'm going to go over 2. Typically it's down 4 then, right, if it was negative, because 2 squared is 4, but I want to multiply it by 3. So I'm going to go over 2. 2 squared is 4, 4 times -3 is 12. I got to go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look at that, I drew my graph pretty decently here. Gave myself enough room. And then I would draw my line connecting my points. Whoop, whoop. Okay, now you've got your graph. It goes down because it's negative. Another trick here, and you're going to need to know this for the assignment, that second assignment. Look at the -5. Look at the y-intercept. It's -5, right? This right here, this thing, is always the y-intercept as well. So you can tell if you graphed it correctly by looking here and going, okay, what was the y-intercept? What did I have it at? Did it match up? Sweet. Did I use the multiplier? Did I go over 1, down 3 like it's saying here? And then if I go over, that would be how you do it. So you've got your y-intercept, you've got your axis of symmetry is x equals -1. We found the vertex using this guy right here. This is key. You're going to need to know it. Those are your notes for this week. 3 examples, a lot of information. Watch this video out twice if you need to. Send me questions as you have them. We're really cruising, guys. We're doing really well. I'm proud of you. Keep up the great work.